Well, good morning, everybody. Thank you for joining us. There are several hundred people listening on this webinar, so it really does show that there is a lot of interest in the products that we're about to see. Before we get into a demo, I just wanted to talk to you a little bit about Edgecam Workflow. Edgecam Workflow is the latest part of the Edgecam product range, which is really designed for the future. It starts with a modern user interface and really based on the sort of the modern look and feel of the Metro style of Microsoft Windows 8. It's going to take you through a 5-stage process where we can look at the first of all loading the parts and then setting it up. Workflow will actually work out what type of environment, either milling or lathe, that the component needs to be manufactured in. And it will sort of automatically set things like datum positions. It will advise on stock and fixtures and machines that you can use, intelligently using the dimensions of the component to help you. It will then look for the features, the manufacturing features that can be made on the component, and once it's sought and found those, it will actually, through intelligent solid manufacturing, work out a plan to manufacture those features. At every stage, the intelligence of the system is helping and supporting you, but as a user, you do have manual control over pretty much everything. So the basic principle is that Edgecam Workflow will give you a default starting position, and then you can manually move, edit, change order if you feel it's best practice for you and your component. Finally, after it's done all of that, it will apply intelligent manufacturing strategies onto the component and finally produce CNC code that can be taken to the machine tool. And as I said, those will be default strategies delivered out of the box. However, you do have the opportunity to either edit individual toolpaths or edit globally the toolpaths that are placed onto the component. The other technology that we're just going to take a look at today is our Waveform. Our Waveform has been out in the marketplace for about a year now, and still we are finding customers who try it for the first time are astounded by the results. There are two massive benefits to Waveform. One is the reduction in machining time for components and specifically difficult materials or large roughing areas. The other one is improved tool life. And what we have found is that people that use Waveform are buying less and less tools. And how does it work? You can see there are two pictures. One is for an internal radius and one is for an external radius. On the internal radius, as you move into the corner, you begin to overcut on the tool. So what we actually do is we actually reduce the width of cut and thus maintain the material removal rate at its maximum level. On the right hand side of the image, you can see that as we go round an outside corner, the actual amount of material that we're removing reduces. So what we actually do there is we increase the width of cut to maintain that material removal rates. And often people ask, is this the same as trachoidal? Our view is trachoidal paths are put into a toolpath to fix problems. Waveform actually went back to the genesis of the toolpath creation such that we don't need trachoidal moves. So I've just briefly described a couple of bits of technology. How did we arrive at this? Why did we investigate? Why did we put the investment into the research and development? First of all, I just want to take a couple of slides to look at the vision of manufacturers. The reality is due to the smart devices that exist today, the opinion of software is changing. And we need to look and we need to consider and we need to think about that. Jobs and machines are becoming more and more advanced. There is nothing we can do about this. This is just a fact of life. So ease of use and implementation is critical. They become more and more critical as jobs and machines become more difficult. However, the value drivers for manufacturers remain the same. Basically, we feel that there are two key elements to why people want to invest in technology. One is to do jobs that they currently cannot carry out. The other one is to become more efficient. And today's presentation focuses on the becoming more efficient element through workflow and waveform. Finally, a reality is that we are in a truly global market. And there are vast differences in cost base across our global market. And ultimately, customers and manufacturers are demanding a better return on their investment. The buzzword of the day, of the week, of the year probably is cloud-based computing. And just like the UK's weather, the future is cloudy. PCs and smart devices must learn to live side by side. And in fact, you could argue that PCs and smart devices are almost turning into one with the type of laptops that we see today, where you can just break off the screen and you've just turned your laptop into a smart device. There are many possible IT options that exist today and will exist in the future. You can host software on your local servers in your own company, or you can host them on the internet and through the cloud. You can manage your servers internally or externally through outsourcing, or you can manage your servers however you feel. You can now purchase IT, but a much more common vogue way these days is having a rental or subscription SaaS model. We at Edgecam believe all of those elements have benefits and have different benefits, and we feel that they should all be options for the future. But the cloud and servers, they're pretty scary terms. However, the web browser, we feel, is a much more comfortable place to be. So independent of where your servers are, we believe that developing software for a browser is an important part of our future. Why? Because machine tools now have browsers. Shop floor PCs have browsers. Tablets have browsers. You don't need to install big leaps of software onto a browser. It just works. So think about this. How about shop floor editing on a browser? Rather than going into an NC file and changing the tool or the feeds and speeds because they're not available, how about editing the CAM file so that you get some traceability, some history, and then you can regenerate the CNC file to be used on the machine tool. And if you can do that on a tablet or on the machine tool or on a shop floor PC, you've made yourself a vast improvement. But after you've done an edit, or maybe you've just received a CNC file, how about having CAM simulation on a browser, allowing you to see the manufacturing process that is about to start on the machine tool? In this area, we have been doing some R&D. And here is a very, I think it's actually a small nexus. And here you can actually see the Edgecam simulation working on a tablet device. The interface has to be very simple, but the graphics there are real time. There is nothing actually stored on the tablet that you see in front of you. And I think you can also see that it's actually quite a small tablet and be carried around in your pocket. So here, the tablet through the browser is connecting to Edgecam and displaying the simulation. How does that affect what we do today? It sets us with some goals that we know that we need to meet. We know that we need a modern user interface. We know that we're going to need a sensible launchpad to launch our applications. We know that we need fewer icons to help the user through the process. We know that we need to be intelligent and offer intelligent solutions. However, manufacturing is not a simple task. Our solutions always need to be flexible. So although they are intelligent and they offer the best practice, we know that the user demands a solution that is flexible and can edit and change anything at any particular time. We need simpler steps to allow the user to take themselves through the manufacturing process, through the workflow, from the file loading to the setup, to feature finding, to machining, to ultimately producing the NC code that drives our machine tools. So at that point, I would like to hand over to Lee, who is going to give us a demonstration of workflow.
Okay, thank you again, Raf and Mike. And what we're going to do is start at the desktop of my PC, and what we'll see is that we've got a new launchpad, as Raf discussed, and this is obviously in line with what we're seeing with Windows 8 with tiles, Metro apps. We'll see that we can scroll through the different areas of the Edgecam applications, but we can also add additional applications. So you might be working with a preferred CAD system or indeed NC editor, Microsoft applications, for example Excel. These can all be added very easily using a drag-drop technique to this interface. So we're going to start by looking at Edgecam Workflow. So down here we'll see we've got 6 applications. We'll be going into these in a little bit more detail shortly, but for now we're going to start with the main application, which is Edgecam Workflow. As we launch Edgecam Workflow, we'll be greeted with a welcome screen. This will give you the 5 stages that Raf touched on, and it will give you some explanation as to what's expected in these 5 stages. And as you can see there, we can move through these different steps. We've also got file management tools. So here we can see the recent items, and I can also pin items. So if I'm working on a particular network location, for example, I could pin some folders here, as you see, and that will make file management much easier. Okay, so with that in mind, we're going to launch a turn component. So what we'll see now is the part loads, and we're presented with another control panel here, which is the setup screen. Workflow has automatically set the part up to be machined on a lathe. Quite easily, we could change that to a milling machine, and again we could change that back to a lathe. Once we're happy with the environment, we can then start to consider the datum position. By default, the datum will be placed on the front of the part, and again we can make changes should we wish to do so. So what we're going to do now is we're going to move ahead, and we're going to have a look at adding some stock material. So I'm going to fit some stock to the part, allowing for material on the front and back of the component. Once we've added the stock, we can now load the part into a machine tool. I'm presented with a selection of sample machine tools, and I also want to select a toolkit. Once we've selected the machine and the toolkit, we're now in a good position to start considering the next stage, which will be feature recognition. Moving across the ribbon in a left to right manner, you can see that we're moving down the stages, which will shortly arrive at generating toolpath. Once we've recognized the features on the component, we're now going to have a look at machining the part, moving down the tab to the machining area. We want to plan the job. Based on the feature recognition, I'd like Workflow now to identify the manufacturing processes that we see here down the control panel on the left side. Although Edgecam Workflow is guiding us, there's no reason why we couldn't change the order. So there we can see that I've elected to rough mill the part before I actually carry out the finished turning. So this is, although Edgecam Workflow is guiding us, it's also allowing us the flexibility to change our mind at any stage. Let's have a look at carrying out some turning. So the dark yellow that we see at the top there is the rough turning for the face of the part, the OD of the part and the groove. So I'd like to execute those 4 toolpaths on a toolpath by toolpath basis. We now see the CAM instructions being generated and the toolpath being applied on screen. At this stage, I might wish to go into machine simulation and verify those toolpaths. So here I can start to have a look at full kinematic machine tool simulation and inspect the results of the toolpaths that were deployed. Once we're happy with that, we may wish to continue and apply the finishing. And once again, we can see that after the roughing, we're now applying the finishing toolpaths. Next we move on to the milling. This is on a 2CY lathe, and we wish to mill the feature on the front, the open pocket and also the drilled holes. So to finish off with, I'd like to execute the subsequent milling operations. As we said, we're going to be machining this part by first of all roughing and then finishing. So there we can see we've roughed out the feature on the front, the open area. Next we'll move to the open pocket on the back shoulder of the component before coming back and finishing and then moving on to the drilling. So as you can see there, a part that would have previously taken a significant amount of time is machined within minutes. The last stage of the process is to move to the NC Code tab. And on the NC Code tab, we've now got the ability to review the tooling that was used on the part. Workflow will intelligently identify tools that were not available. So unfortunately, in my toolkit, I didn't have a 2mm end mill available. I can elect to add that to the kit, and furthermore I can also renumber the kit. So we now have logical tool numbers. We can close and acknowledge those changes before regenerating the toolpath sequences. The last stage of the process, of course, is to generate the NC file. And this is the final stage of the process where we will generate the NC file, and very quickly we'll see that we have NC code ready to go. So there we have a sample program, an ISO program, that we've generated within 2 to 3 minutes. Okay, so that was fairly quick. What I'd actually like to do now is open up a milling component, and we're going to walk through this process a little slower, and I'd like to explain some of the technology on the way and also introduce an element of flexibility. Okay, let's start back at the beginning. So we introduced the Edgecam launcher. As I say, we can use this to launch Edgecam applications, recent files, but furthermore we can introduce some of your own personalized applications, i.e. CAD systems, NC editors, etc. One of the items I'd like to touch on here, which we'll be looking at inside milling, is the introduction of the Fixture Manager. And I can't stress enough that everything that you're seeing on today's presentation is true out-of-the-box technology. The devices that you see here will be shipped as a standard library, but of course you might want to add your own vices, clamps and fixtures, and this can easily be done through the Fixture Manager. As well as the Fixture Manager, we've also got a Stock Manager. The Stock Manager will basically allow us to create a library of stock material, which in turn Edgecam Workflow can use to machine the component once we get inside Workflow. As you can see from these managers, they're very interactive and very graphical, which will of course aid in ease of use. So with that in mind, let's relaunch Workflow, and we're going to have a look at a milling component in a bit more detail. So once we arrive inside Workflow, as I said on the previous demonstration component, we have a welcome screen. Once you become familiar with Workflow, of course you can elect not to display this screen every time. Starting at the back stage of the process, anyone who's using, for example, Office 2010 will be familiar with this look and feel of the theme of Workflow. We've got file management down the right side, and also the recently used folders, and indeed the pinned folders. Let's have a look inside this part here that we see, which is a mill component. And again, as Raf discussed on his initial presentation, Workflow has the intelligence to identify that this part more than likely will be produced on a mill. We can see that it's coming on a milling machine here. When it comes to datum and position, you'll see that we have the interactive control panel here where we can start to elect the position of the datum. As you see there, I'm electing for the top right of the component. We spoke about the stock manager. If we choose a piece of stock from the stock manager, what we'll see here is three conditions. Green is valid, yellow is nominal, meaning that we can just about make that without cleaning up the outside, but also there's a list of invalid stocks that would not be capable of making the part. So again, it's adding intelligence to the manufacturing process. If I was to select a valid stock, I can then decide how I want to position the part using the interactive control panel here that we see. So if we say that we were going to select this stock, you can see there that, well, there's going to be a lot of waste material if I was to go down the manufacturing process with this stock. Okay, so how do I change my mind? Well, that's not a problem. If I say, well, actually we want to fit some stock, Workflow will react, it will detect that there's already stock present, and now we can come into this area here and start to create a custom stock. We can add different offsets to each side. We might not have equal distribution on each side, and this allows for full interaction when creating stock on the component. We spoke about the Fixture Manager, and the next stage once we've added stock is to go to the fixture database, and we can elect to select a particular vice and orientation, and also we have an automatic calculation for part stick out. In other words, what parallels would I use, how much protrusion would I have. Very quickly you see the vice placed in the component, or indeed the component placed within the vice, but there was zero interaction from me there. I didn't have to elect the jaw grip or the position. Edgecam understands the stock and the component condition, and with that information automatically adds the vice correctly. As with the stock, if we were unhappy with that fixture or vice, we could go back and recreate it. Let's move on to the final section in this stage, selecting the machine tool. Here we're presented with a series of machine tools, and with that we can also select a kit of tools. In this example here, I might have a carousel of, for example, 50 tools, and I only want to use the required tools from the carousel. Therefore we can choose to create a copy of the kit and move ahead. Next we carry out the feature recognition, and we start to find the features around the component. So you can see we've got a good array of features on this part. We've got some 2D pockets, we've got some open pockets, We've got some islands in there, some bosses. So we want to try and show the power of workflow on this, this different array of features. Let's have a look at some machining. What we'll see here is the ability to plan the part. And I can't stress enough that this is out of the box what we're seeing here, but this is obviously it's a user's preference. The user may wish to carry out a certain set of commands in a different order. So you can see here how I have the interaction with the planning board, which will obviously allow flexibility before deploying the automation. With that in mind, let's apply the automation. So using the apply button, we'll now see that we're moving around the component in the order that I planned the job, which was to rough all the pockets, then to finish the pockets before moving on to spotting of the holes, drilling, counterboring and tapping. I think at this stage it's also important to mention that the tapping information that's come with this part is obviously made possible through Edgecam's Solid Machinist technology. This part can come from any CAD system, and with the technology that we use we can load in the CAD data and also the threading information. Once we've finished the holes, let's have a look at some of the toolpaths that we've been presented with. So at this stage I might want to start making some changes to these toolpaths, and this is really about having the power of automation alongside the flexibility of the manual intervention. So for example here we've used a traditional concentric strategy, and I want to have a look at changing this to waveform. So by interacting with the toolpath we'll see I can change this toolpath within 2 clicks to become a waveform strategy. And Raf will be talking about waveform in a little bit more detail shortly. This is very unique how we do this in Edgecam. It lives within the roughing cycle, the core cycle, and it's simply one parameter change, recalculate the toolpath, and very quickly there what you'll see is we have a brand new toolpath. Very easy, very quick to do. Okay, so that's fine if I want to change that on a toolpath by toolpath basis, but I've also got several other pockets on the part and I don't want to have to do that several times. One of the other features on Workflow is the ability to optimize. Once we select the optimize, what we'll see is that 30-40 commands will now be reduced and optimized to around 20 CAM instructions. And what Workflow is doing here is it's inspecting the common parameters of each of the toolpaths and it's merging them and consolidating them into the one toolpath. And this gives us 2 benefits. First and foremost, it will give optimized cycle time. The passage between the pockets will now be considered and the shortest route taken. This will obviously give us good cycle time reduction. The second benefit is that the sequence will be reduced. So on a more complex shape, we'd anticipate around a 30-40% sequence reduction. So now you can see that the 4 pockets are machined with the 1 cycle. Very quickly we can go back in, make the change to waveform, and we see the global change. So we've had a little look there at the automation deployment that comes with Workflow. Again, this is out of the box. You could do this from day one. We've also looked at the flexibility of editing toolpath, but what about if I actually wanted to add additional toolpaths? So for example, I'd like to delete the toolpath that we see here, and I'd actually like to add my own custom toolpath. So once we delete that, how do we re-add toolpath? What we'll see in Workflow is we have an advanced area. As soon as we activate the advanced area and move to machining, I'm now presented with the more traditional manual Edgecam commands. So with that in mind, I'd like to actually insert this instruction partway up the sequence. So we'll see here I can interact partway up the sequence, and what I'd like to do is add a roughing cycle. For existing customers of Edgecam, existing users, you'll see that there's been some significant changes with this dialog. We've added the pictures to the dialog. As we move through the dialog, we've got online help. But more importantly, the geometry selection is much more interactive, much more improved. I have a prerequisite here, which must be I must pick some geometry. So let's interact with the first button. The feature to machine is the open feature. Once we've acknowledged that, you'll see that we have a tick, which is just confirming the selection, and we can move ahead. A boundary. This is an optional preference. You'll see by the designated underline, I must have geometry to machine. However, I don't necessarily need a boundary. So let's move ahead and apply the toolpath. Very quickly there, we see that I've now redeployed my own custom toolpath. So really, I just wanted to conclude the demonstration there by saying that, automation can live alongside manual CAM instructions, and if you can make any percentage of saving by getting the repeatable features machined using workflow and then interacting for the more complex areas of a component, it will obviously present you with some savings. Finally, before I hand back to Raf, I'd just like to talk about where does the automation come from. The automation that we're using to deploy the planning board and workflow is what we can see here. It's basically a flowchart, and it's using the parameters from Edgecam, the commands from Edgecam, and here we've got a very simple example which is showing a decision-making process on drilling a hole. If the hole is greater than 25 millimeters in diameter, then we've elected to go down the route of making a pre-drill, a pilot drill. Once we've pilot drilled the hole, we then come back into the main flow and select a tool that will finish drill the part before terminating the sequence. That's a very simple decision-making process in isolation. Obviously, we can make much more advanced, complex decisions. For example, we can make decisions based on the job, the material that we're cutting, or indeed the machine tool that we're working on. So this is a very powerful tool, and you do have the ability to edit and create your own routines, but what we're seeing today is, once again, it's out-of-the-box technology.
Okay, thanks. Can you hear me loud and clearly?
Loud and clear.
Excellent. Okay. So what we would like to do is just recap on what we have just seen. Workflow, where we load the file, we set the file up, we find the features, we do the manufacturing, we produce NC code. We've seen both turning and milling demonstrations. And also, obviously, what you had there was a component with both turning and milling features on it. We saw rapid manufacturing, but just as important as rapid manufacturing is the ability to modify the manufacturing process and add manufacturing processes. So you can modify a single toolpath. You can modify a group of toolpaths. And if you wish to implement your best practice, you can actually go to the root strategies and actually change it. I think Lee's example strategy had a 25 millimeter question set. Well, maybe in your environment, maybe it's 20 millimeters, or maybe it's 2 inches. The reality is we've put our best ideas into the strategies, but they are there for you to take and implement your best practices. I hope that we've shown milling and turning. I believe that we've shown reliable code production. We've seen how code is repeatable. We've seen how fast we can produce code. And yet we've also shown a good degree of manual control. At the moment, workflow is limited in its Edgecam capability. We're targeting the sort of the 2.5D, the simple mill turn, but I've got to be honest, it isn't long before we're going to be doing 3+2 properly, and precisely pretty much all of Edgecam is going to be based on workflow. One of the quick things that Lee spoke about was Waveform. We've recently held a day at Seco Tooling in the UK, and I would just like to share with you a video that we made during the day. So this is a Waveform video. I hope you can hear me, showing the capabilities and some of the parameters of Waveform. Edgecam Waveform is a high-speed machining technique. It creates the best toolpath to machine a component. The feeds and speeds that we're achieving, most people find difficult to believe until they've actually tried it themselves. I think you'll see that, especially in the more difficult materials, it provides a huge advantage. So, you know, the lead-ins, the helicals, we support pre-drilling, but I think the helical lead-in is the sort of default parameter for the cycle and has a 3-degree angle to get the chips out of the components. And as you can see, the chips do travel at some rate. One of the questions that we're often asked is, well, how much does this technology cost? You know, how much is the extra option? Well, actually, it is not an extra option. It's included in the standard Edgecam milling license. So pretty much most Edgecam users have this technology available to them. And I would really, really encourage them to try it out. And I would really, really encourage them maybe to get us involved or your resellers to find out what feeds and speeds could be achieved. It obviously works with all manufacturers of tooling, even though this example was made at the Seco Open House. So now we'll see some outside machining, and you'll notice that after a pass it goes up and over back to the start point. Edgecam Waveform intelligently works out, is it quicker to go up and over, or is it actually quicker to do a small lift off and move around the pass back to the pass? So there you could see it then made the decision not to go up and over and to just go around. So reduced machining time and tool life are the two key elements that come with Waveform. And as I said, Edgecam users have it in their software, and I would encourage them to try it. And as I say, you know, if they have any concerns, please contact us and we'll support that. So, what are the benefits to workflow users? Improved deployment. Everything that you've seen today has not been set up. It's not custom in any way. What you've seen today comes out of the box. We believe because it comes out of the box, we're going to have a reduced implementation time. Because of the simplicity, we believe that there's going to be a reduced learning curve for people to use it. We have a reduction in programming time. We have a reduction in machine tool time. And we have an increase in tool life. And I think if you add all of those key elements up, then I hope we show that you're going to get a better return on your investment. So, in conclusion, we've labelled the webinar and this work as changing the game. And I hope that you have seen and can see the possibilities of the future. If we stand still as manufacturers, then our competition will overtake us. And I challenge you to try these new technologies, change your game, improve, be ahead of the pack. So at that point, I think the official presentation comes to an end. If you want to know more, then please take a look at our website, edgecam.com/workflow, or email us at workflow@edgecam.com. If you're particularly interested in our Waveform technology, take a look at edgecam.com/waveform or email us at waveform@edgecam.com.